So today we are going to begin chapter 1, and we're going to break up section 1 into 2 days. So today is the 1.1.A, and we're going to learn how to solve linear equations. So we're going to get right into some examples because this is something you should have seen. We did a lot in geometry. No matter what Algebra 1 you took, if you took it here at McCarthy, this was taught in Algebra 1, regular and in honors. So our goal here is to find the value of x. So we need to first distribute, then we need to combine like terms, and then isolate the x. So we're going to first distribute. So I'm going to distribute the 3 first to the 2x. And then I'm going to distribute the 3 to the negative 4. Then on the right side of my equation, I can either assume that this is a negative 1 that needs to be distributed, or just distribute the subtraction sign or the negative sign. So I'm going to distribute it, and I get a negative x minus 5. Now I'm going to combine some like terms on the right side. So on the left, I'm just going to rewrite it. And then over here, I could get 2 minus x, or if you want to do negative x plus 2, whatever way works for you. Then now I'm going to begin grouping my x's. You need to move your x's to one side and your numbers to the other. I'm going to move my x to the left. I like letters left. So I'm going to move that over, and something happened there. What happened? Let's see. Nope, that's right. So then now I get 6x plus 1x minus 12 equals 2, because the x canceled from the right. Now I'm going to add 12, and I get 7x equals 14. Divide by 7, and I get x equals 2. So I expect to see this type of work in your homework that you turn into me. If you're going to just write the question and then tell me that x equals 2, you're going to get a 50 for your homework. You must show work in order to get the 100. Okay, let's try the next one. Everybody good on number 1? Mm-hmm. Number 2, we got lots of fractions going on here. So I'm going to teach you a way to eliminate the fraction by multiplying all of the terms by the common denominator. So I'm just going to rewrite the problem here. 1/4 x minus 7 over 3. So out of those numbers, the 3, the 2, the 4, and the 3 that are in the denominator, what would be my common denominator here? 12. So what I'm going to do is I'm going to multiply every single term by 12. So essentially what I'm doing here is 12 over 1 times this one, 12 over 1, 12 over 1, 12 over 1. Now, to make it easier, just simplify. Make this a 4. So then now what I'm going to have to do here is 4 times 2x plus 4. Then this term, simplify, and it turns into a plus 6x. And then here, turns into a 3x. And then finally at the end, this is going to simplify, and 4 times 7 is 28. So now I've cleared all the fractions. So I'm going to distribute the 4 to the 2x and the 4 to the 4, giving me 8x plus 16 plus 6x equals 3x minus 28. I'm now going to simplify that left side. I'm going to add together the 8 and the 6, giving me 14x plus 16 equals 3x minus 28. I now need to get the letters on one side and the numbers on the other. So I'm going to move the 3x to the left by subtracting it from both sides. And I end up with 11x plus 16 equals negative 28. I now have to move the 16. 11x equals negative 44. And then divide by 11, giving me x equals -4. Now, some of these steps you could probably do in one step together, but really you need to try to stay as organized as possible in this course, because one bad multiplication or one bad sign and everything's going to be messed up. So you really need to, develop a good, strong work ethic and, start setting these up and solving them organized. Now, also keep in mind that as you get into the higher level math classes, you might get a 5-question test because one question may take you an entire page to solve. So if you start out now with a nice, good, strong work ethic, then by the time you get to those upper level math classes, it's not going to be a shock. Anybody still need number 2? Question? All right, so for number 3, again, I need to distribute and then I need to combine my like terms. So I'm going to distribute the 4, and that's going to give me -8x plus 4. Then I'm going to notice again, I'm going to distribute a -1, and this is going to give me 6 minus 2x plus 4. I now can group my like terms on the right, the 6 and the 4. When I add those, I get 10. So 8x plus 4, I'm just going to rewrite, and then -2x plus 10. Now I can begin my properties of equality and group my like terms. So I'm going to add 2x. Now also remember, you can move the 8x to the other side by adding it. It doesn't matter which way you move it. You're still going to get the same answer. So then here, this will give me -6x plus 4 equals 10. And then move the 4. And then I'm left with -6x equals +6. Divide both sides by the number next to the letter, which is -6, leaving me with x equals -1. Now, remember, whenever you're solving an equation for x, you can always take your answer and plug it back in. If this side does not equal this side when you plug it in, then you've done something wrong. So that's the way that you can always check your answer. For number 4, I am going to work within the brackets first. So I'm going to rewrite the 4 and the bracket. I'm going to distribute into the parentheses first. So this will become 2x minus 3 plus x plus 5, and then I'm going to close the brackets, and then it equals -7x minus 2. Now within the brackets, I'm going to group my like terms. So I'm going to group the x's, and then I'm going to group the constants. So here I'm going to get 4, the bracket, 2x plus 1x is 3x, and then -3 plus 5 is 2, equals -7x minus 2. I now have to distribute the 4 to the 3x and to the 2. 12x plus 8 equals -7x minus 2. I now need to group my like terms. So I'm going to add 7x. I get 19x plus 8 equals -2. I now need to move the 8 by subtracting it. 19x equals -10. Divide by the number next to the letter. And then I'm left with x equals -10 over 19. Pretty good on that example. So on number 5, again, we have a fraction to get rid of. I've got to find a common denominator between 5 and 3. Good. So let me rewrite the problem. 2x plus 5, x plus 2. You could work with it and show how you're going to multiply it up at the top. So I'm going to multiply my whole thing here by 15. Now, notice that over here, this is being multiplied together. So I do not need to multiply what's in the parentheses. The only thing I'm going to multiply by the 15 is the 1/5. So this would give me 3, and then the 2x plus 5. And then over here, when I multiply this side by the 15, I'm left with 5, x plus 2. So now I need to distribute on both sides of my equal sign. So when I distribute the 3, I get 6x plus 15, 5x plus 10. And now I can group my like terms. So I'll move the 5x by subtracting it. And then I'm left with x plus 15 equals 10. Subtract the 15, and x equals -5. Now, notice on this one, it's mixed with decimals and with a fraction. What I'm going to do is, I'm not going to try to make the 2/3 into a decimal because it's going to give me a repeating decimal. Instead, does everyone know, this is a 0.25 if you're not sure. Does anybody know the fraction equivalent for 25/100ths or 0.25? 1/4. So instead, I'm going to change that into 1/4 x. Now, I need to find a common denominator. What's it going to be? 12. So I'm going to multiply the whole thing by 12. So my first fraction, when I do 12 times 2/3, that's going to give me 8x. When I do the 12 to the 1/4, that's going to give me 3x. And then remember, this is a grouped quantity, so I actually have to distribute it to both the x and the 2. Even though it doesn't have a fraction, you need to keep this balanced, and you need to do it to every term. So then this would become 12x plus 24. I now can begin to group my like terms. So when I group these two, I get 11x, 12x plus 24, and now I can move the 12x over, and I get -1x equals 24. Divide by -1, and x equals -24. Remember, you can never have a negative variable, so that's why I needed to divide by -1. So, first of all, we've already talked about number 2. This is a screenshot from your textbook. We've already talked about number 2. So whenever we solve a linear equation, and if we end up with a single solution, like x equals 3, then that's called a conditional. Now, I'm not going to expect you to know contradiction, conditional, identity, but if you ever happen to see these words on a standardized test, you can, maybe remember that an identity is when your answer is all real numbers. So it's like the same thing equals the same thing. A conditional is one solution, a single solution. And then a contradiction is the empty set or no solution. And we're gonna go ahead and solve our next few examples, and then we're gonna see the two situations of all real numbers and no solution. So we're gonna go ahead and solve number 7. It's pretty simple. All we need to do is distribute and then begin combining our like terms. So I need to distribute the -2 to both of the terms in the parentheses. And I'll rewrite. I'm going to group my like terms on that left side. So -2x plus 3x will give me x minus 8. And notice at this point, if you can immediately recognize that x minus 8 is equal to x minus 8, and it's exactly the same thing on the left side and as the right side, you can right now write all real numbers. However, if you didn't realize that and you keep solving, then you're going to be left with, this will cancel, x equals x, and even if you try to group your x's, you end up with the equation 0 equals 0, which is a true statement. So if at any point you end up with a true statement, then you will say that the solution set is all real numbers. You can either abbreviate numbers that way, or you can write out the word numbers. So as soon as you see both sides of your equation are equal, the solution set will be all real numbers. Again, nice and simple. We're going to distribute the 3. So 3 times 3x is 9x. 3 times -1 is -3 equals 9x plus 7. Now at this point, if you notice that the variables are identical, once we try to solve this, I'm going to be left with some nonsense. I'm going to be left with -3 equals 7. Will that ever occur? No. So as soon as you're left with something that there's no variables left and it doesn't make sense, your answer is no solution. You can either write out the word no solution, or you can put the 0 with the slash. You could even put an empty set brackets. This indicates that there is no solution to this problem. Now, on number 9, notice I have a fraction, but I only have one fraction in the problem. Now, for this one, I'm actually just going to distribute it because I can very easily find half a 6 and half a 14. Now, if it were something that didn't go in evenly, then I would do the trick with eliminating the fraction. But I'm actually going to just distribute the half to the 6 and the half to the 14. So half of 6x would be 3x, and half of 14 would be 7. And then I'm going to distribute the 2 on the right side. And now I'm going to simplify that right side. So I can group my x's and I can group my numbers. So over here, I still have the 3x plus 7. Over here, when I group the two x's, I get 3x. And when I group the two numbers, I get 7. So again, at this point, if you realize that both sides of your equation are identical, you can just stop here and say all real numbers. Or if you need to go ahead and finish solving it, you could try to subtract the 3x. It cancels from both. Then you're left with 7 equals 7, which is still a true statement. And if you want to take it all the way to the bottom, 0 equals 0, it's a true statement. So this answer is all real numbers. All right, number 10, I am going to distribute first the 6 to both terms, or the -6, and I get -12x minus 6, distribute the -3, and then rewrite the right side. I'm going to group my like terms, so I'm going to group my x's, and I'm going to group my numbers. So -12x minus 3 will give me -15x. And then -6 plus 12 gives me +6. Drop down the right side. And right away, I'm going to see I have the same variable on both sides, but it's not being added by the same number. So when I go to try to group my 15 x's together, I'm left with 6 equals 1, which again will never happen. So this is another no solution answer. I'm going to show you one more example with decimals. It's not in your slides, but I just want to show you how you could get rid of the decimals. So this is actually number 28 in the homework, but you're only doing odds. So in order to clear a decimal, I can multiply by 10, 100, or 1,000. And in this particular problem, if I multiply the whole thing by 100, it'll clear my decimal. Now, also, another way to think of it as is just move the decimal point the same number of times in each term. So if I move this one 2 times, then I have to move this one 2 times, and then this one. And then it's all cleared out. So now I'm just left with 4x minus 12 plus 6x equals 152. Now, you don't need to worry about putting the decimal point back in when you're done. As long as you did it to every single term, it works out. Now, if you like working with decimals, you can leave it there and still do it. So here I have to distribute. And then I'm going to group my like terms. So 4x plus 6x gives me 10x minus 48 equals 152. Add the 48. 10x equals 200. Divide by 10x, or 10. Cross off one of the zeros from the top and the bottom. So x equals 20. So as long as you move the decimal point the same number of times in every single term, including the answer, you don't have to adjust anything in the end. It makes it a lot simpler. Yes?
My notes only has to number 10.
Your what?
My notes only goes to number
Right.
10.
Yeah, but this is an extra one.
Yeah, I added this.
Oh, okay.
Okay. Okay. So I added this one in because number 27 in your homework does have decimals. So I wanted to add one more example to this so you could see how that would work. Any questions on that? Okay, so your homework is on the next slide. I'll leave this here for a minute though. It's page 90 and 91, and you're doing 9 through 35 odds. The solutions are in the module. If for some reason you're not seeing everything, go out, go back in. I'm not sure what's going on with Canvas at the moment, but the homework should be up there as well as the solutions. Now on Monday, we're going to continue section 1, and then the solutions for both tonight's homework and Monday is in the same solution file. So when you're doing your homework, you're showing the work and you're also checking it. And then that way when you come in the next day, if you still didn't understand after you checked, that's when you're going to ask me to work them out. If you're not doing the follow through with the homework, again, the tests and the quizzes are going to be a bit challenging. Okay, so again, homework is on this last slide. It's also on the assignment when you click on it. And it's due Monday. Any questions?